Hi everyone, and welcome to today's webinar here, talking about rated power, a part of Inveris. The topic of today is going to be deciding on storage, integrating your best solutions with rated power and Prism, really looking here at integrating and having hybrid projects with your PV solar plants. So again, deciding when and how to add storage to your solar PV projects. And welcome again for joining us here today. So your speaker today is me. Just a little bit about myself. I work here at Inveris as a power and renewables principal consultant, working in the US market. My background is in electrical engineering, and that's what I got my formal education in. And I am a rated power expert on the team, if you will. Really, my passions are robust design, renewable energies, and grid reliability. And then again, leading North American clients in both rated power and Prism platforms. And we'll talk about a little bit of both of those here today. My contact info down below if you ever need to kind of get a hold of me, talk a little bit more about either of the platforms. I'd be happy to connect you with anyone on the team, maybe even including myself as needed. So today, during the presentation, we're going to be looking at 4 different parts. We'll start with a quick introduction, so talking a little bit about what Prism is, what rated power is, and then we'll move on to how do those two platforms really work together, where does the synergy lie, and how do they complement each other. Number 3 is going to be the most exciting part for the both of us. So actually looking at sort of a quick greenfield siting workflow, and then also design within the actual rated power platform. So getting to see a little bit of the best of both worlds and how they directly interact with each other. And then to kind of wrap things up and conclude, we'll be talking directly to you live here in a quick Q&A session. So again, if you have any comments, questions, things like that regarding the presentation, we'd be more than happy to hear from you. If you have any questions, I won't be monitoring that directly during the presentation here. But if you have any that come into mind, feel free to pop them into the chat and I'll make sure to address them towards the end of the presentation when we get there. All right, so introducing our products today, both Prism and Rated Power. I'm just going to kind of go in order here, since to me they kind of slot chronologically in terms of when I might actually use them, putting myself in the shoes of a developer, engineer, EPC, those sorts of things, to kind of go ahead and find my initial project space to actually going ahead and starting that initial engineering design. So just to introduce Prism, that's our GIS analytical platform, bringing together disparate data within the energy sector into one central space. So the software includes geospatial data, tabular data, data filtering, and then dynamic charts that interact directly with that data so that you can interrogate the data and make connections that might otherwise go unrealized. And here I just have a quick little screenshot of dashboard that I love to personally look at, just to kind of show how the interconnection queue is looking, and the different charts and graphs that help to describe how much more projects and power plants have been added, say, over the last 10 or 20 years. So really Prism being that upfront vehicle to go ahead for research, siting, and kind of anything within the energy sector. That's going to include different layers like power plants, transmission lines, substations, LMP info, land layers and suitability, which we'll talk about a little bit today, as well as things like congestion analytics, IRPs, or those integrated resource plans, RFPs, etc. One caveat that I should mention about Prism, it's primarily the North American market that it focuses on, and most of the data that we'll have pertains directly to the US. So for any of our kind of international clients, know that this platform really is currently focused on the North American market, particularly the United States. And moving on to the second half of today is going to be rated power. So most of you probably watching this before have seen or utilized rated power in some way, but just for a quick reintroduction and for those who are perhaps new, rated power is our software to quickly optimize and streamline the design and engineering process of utility scale ground mounted PV plants, your best storage solutions if you're doing a hybrid project, and then also the interconnection facilities. So thinking about things like your on-site either switching and breaking station or substation, as well as your, say, outgoing transmission line to wherever you're going to connect into the greater grid, whether that be half-mile away or a few miles maybe to the next closest substation to your site. And with that being said, where do we go next? And that's how do the two mesh and actually work together. So I call it a power duo just because there is so much overlap, especially in kind of that developer EPC space of going ahead and bringing projects from this kind of idea of I'm not sure exactly where to place the project or what it might look like to actually going ahead and developing that first kind of initial engineering design. So today we'll kind of be looking through a greenfield siting workflow that I mentioned earlier to find attractive locations for, say, potential project development. So on the left-hand side here, showing how we might actually assess some of the land and say in green what's buildable and these other layers what's not, or really to kind of encompass things, what are maybe a few of the main things that folks like yourselves would look at, or I would look at putting myself in your shoes for attractive places to develop in today's market. Those might be things like pricing. Of course, everybody that's developing a project wants to make a return on their investment. So understanding LMPs or locational marginal pricing in those markets to understand those pricing implications. So what kind of return can I expect based on how do I expect to sell power at those different prices during that time? Congestion analytics. So understanding the availability of the grid or maybe where there might be constraints. So really, when we develop any sort of project, in theory, we could put it in most places. But of course, if we're actually going to have to send power to the grid, having some sort of proximity to a nearby, say, substation or transmission line is going to be a massive advantage in terms of project cost. And then also making sure that wherever we interconnect has some form of availability so that we can actually sell and distribute our power to the resources downstream or to adjacent substations to kind of balance out the grid. And lastly here, looking at land suitability. So again, the pricing, the congestion, and the grid availability all kind of have to add up. But we also need to make sure that the land is actually suitable from a buildability standpoint. There are still large swaths of farmland and other kind of flat areas that are, say, easier to develop on from that standpoint. But because of the kind of more intense competition lately and more developers getting in the game, it's very crucial, especially in today's day and age, to kind of locate the parcels that accommodate for those project requirements as sourcing the different pieces of land and we start to build on more difficult terrain or maybe areas closer to urban centers. And after kind of deciding on wherever we want to build based on these variety of different parameters, then we translate here directly into rated power. So importing that site footprint, or rather defining it, selecting the equipment, any layout and kind of engineering characteristics that we want to apply to our PV plant, BESS and interconnection facility, and then actually going ahead and iterating on the designs as many times as we need to find really kind of the best design that we can create in terms of maybe efficiency, LCOE, things like that. And if we need to change out equipment and so on, to arrive at those kind of designs. Again, whenever we kind of finalize our project design, we'll have 400 plus pages of documents created with those different designs to actually be able to bring into those later stages. So just kind of prompting us directly before we kind of hop into Prism and rated power here. So why are we going to use BESS with our solar plant, or why does the industry use it in general? Just wanted to quickly point out that roughly a third of all solar PV projects that have entered the interconnection queue since 2020 are co-located with some sort of paired asset, such as solar PV plus BESS. It's becoming more and more widespread that whenever folks are entering the queue with their different kind of solar projects, that some sort of storage or other kind of generating asset be paired with it. And really, what are the advantages of that? It helps to balance electrical loads, so across the grid at large, as within your plant. Stabilize just overall generation. So for those kind of dips, when say clouds pass over, or you have maybe a little bit cloudier or shaded day, to kind of stabilize your generation and the output that you're proving to the grid. And then overall grid reliability, as one could imagine, the more sort of storage or reservation that we're able to have as a whole, improving grid reliability, and not to mention the fact that, of course, being able to buy up power or sell it at advantageous points is also great for a financial incentive. So now getting into the actual siting and design workflow. So I'm just going to share here or change how I'm sharing the screen. And you'll see in just a second, it'll be bringing up a Prism workbook. Right about now. All right, that looks good. And I'm just going to turn off my camera during this point, and I'll be back on when the slideshow resumes. All right, so letting the product here take center stage. We're just going to be working on a greenfield siting exercise. This one I'll just be focusing on Texas or the ERCOT market at large. Again, Prism being focused here, mainly North America and the US at this time. So just starting out with that different workflow, like I kind of mentioned, how does Prism actually fit in? So just taking a quick look at making sure my pricing, my grid availability, as well as my land suitability all make sense. So here I have those locational marginal prices kind of scattered across Texas, and you'll see that I have these colored by the average solar weighted LMP. So when I'm looking at that average solar weighted LMP, I can kind of see in these top different counties for Texas that I'm seeing anywhere from say $80 to $50 on average in terms of pricing over the last year day ahead market. But of course, I want to be able to have a project that's going to give me a solid financial return. So saying here, I actually want to go ahead and quickly bring up the top nodes. So here using Prism, just being able to quickly filter down to that smaller subset. Picking here on my solar weighted LMP, let's say I want at least an average of $60 per megawatt hour over that specific time frame. And now we can quickly see where most of the areas in the state don't necessarily meet that criteria, but I'm left here with a quick subset that actually does. Given that there's a high proximity towards kind of San Antonio, Austin area, maybe we'll go ahead and just zoom in there to find us a quick location that we might be able to work with and bring into rated power. So now that we kind of have a basis for locational marginal prices that meet our general criteria, we might go to the next logical step of saying, okay, let's go ahead and turn on ATC, or available transfer capacity. Again, this more so being the actual ability for us to actually place things on the grid, or say how much overhead is there at these different substation bus bars throughout the electrical system. And I'm just going to kind of bring those here to the back, and let's just make them a bit larger so they're easier here to see. All right. Just quickly adjusting my color schemes here so it's a little bit easier on my eyes. I can see a variety of different nodes. However, if I want to make sure that essentially I'm meeting my criteria for whatever project size that I want, maybe I want to develop, say, a couple 100 MW solar or something. I'm going to come over here to my filter drawer one more time, and then let's look for ATC once more, and say when I'm running, I want an average ATC value or available transmission capacity, say, of at least 500 MW. I know I said my project size of only 2, but I'm thinking of having a little extra headroom in my analysis. One, so that I'm not constantly kind of hitting the ceiling in terms of how much is available overhead room at that substation, as well as for any potential incoming projects that might already be ahead of me in the queue for that substation. Okay, here I'm seeing a whole number of substations that essentially meet that criteria. However, I see one that overlaps in terms of kind of that higher pricing here in deep purple, as well as has solid overhead potential. Let me take 1 second to just add a quick line chart just to kind of visualize that available transfer capacity. So just quickly kind of adding this here to my page. I can see that a lot of the substations here are seeing anywhere from headroom of 800 to 2,000 MW approximately. But let me just kind of zoom into this San Marcos area, maybe here in the middle. Where I'm able to kind of gather those different sources. And say this one in particular looks good in terms of high pricing and that direct overlap with that substation. Let me just look at the actual substation name. Okay. And then if I just want to look at the availability of this particular substation, I might just go ahead, copy the name, click on ATC, and then actually filter to it directly here. All right, so for this substation, since kind of the beginning of 2023, we're seeing on average anywhere between 600 to 900 down back to about 500 MW of AC. So this one kind of meeting that general requirements for overhead room. At this point, again, I might want to make sure and just be solid on the actual location to interconnect. So here I might go ahead and create transmission. Turn on that transmission line, and then say I at least need a voltage of 138 kV for my facility. Here's where I can actually be sure to go ahead and set for that. Now that I kind of have all the assets that I need, now is where I can start to look for land, perhaps with turning on my parcels. In this case, we're going to see a whole bunch here that kind of cloud our view. But of course, if we're developing a large project, say at least 200 MW around those parts, I'm going to need really a large swath of land. So the last kind of filter that I'm going to go ahead and set up here for this workflow is just saying, hey, I need at least a contiguous acreage of some set limit maybe I need at least 800 acres minimum for the type of project that I'm looking to develop. So very quickly, I'm able to see a subset of those parcels that kind of meet the criteria. And from our desired substation location here, we're able to see that there's a number of parcels kind of up here that meet this general criteria. And just selecting quick to our satellite view and zooming in, I can kind of see that these ones overlap with maybe like a state or local park, the Purgatory Creek Green Space. Maybe the closest one to that adjacent transmission line that may look available would be this parcel here. From this point, I can actually go ahead and do a full land analysis. Just for the sake of time today, I've already done this ahead of time. And just to show you what that looks like, you're going to see here on my screen where I ran our CBA, or customizable buildable acreage model, and basically told the system what is the minimum buildable area that I want to work on, how far away are my default setbacks going to be, and what different layers should I look out for and basically say are restricted areas or unbuildable, unsuitable for development. And here we have as a result anything in green being buildable, and then anything in these different colors unbuildable for a variety of different reasons. And this is really where the magic of the two platforms come into place. Now that we've kind of gone and sited and done that initial check to make sure location that we want to potentially develop works in terms of land suitability, general pricing, and availability on the grid, here's where we might turn to the next step. When I went back and I was looking at that parcel in the ATC, we did have some overhead room for our substation, although we saw some dips and rises, as well as more projects that might be entering the queue. So this average ATC definitely could go down if more capacity isn't added. And so I think if we're developing a solar project, it would definitely be prudent interconnecting into this line near this sub to have some sort of solar to kind of even out any of those bumps and provide kind of any extra power that we need during those times of shade or non-sunlight hours, still during peak hours of the day. So what I'm going to do is I'm going to export this file, just using this up here, which I've already done, and it's actually going to grab all the shapes that I have in the background. So while I'm doing that, I'm just going to stop sharing my screen here real quick, and again switch. And I got logged out here of my rated power instance, but just coming back in. Just 1 second. I'll take us directly to where we can actually import that problem. So quickly navigating here to the project I had set ahead of time, just have a blank slate. But if I click Start Design in the top right-hand corner and then go to my site location, this is just where I'm going to actually be defining that site footprint. And since I've been using Prism and already generated those different layers using our system automatically, I can just select Import Site Info. And then here I'm just grabbing that zipped file for that shape file that I created and bringing it directly into our platform. So just making that quick selection and import, you're going to see how our system automatically recognizes exactly what's going to be buildable and then what areas are restricted. Coming to this next step, I'm just going to define where our access point is going to be. And then I just have to define a substation. So let's just say I'm going to put my substation over in this part. All right. Might have to redraw that here. Never claimed to be an artist, that's for sure. All right. So reselecting on this substation. Just defining that footprint here and selecting a medium voltage point whenever I'm ready. Sorry about this, folks. My internet is acting up a little bit here, so I'm getting some weird shapes as I'm kind of trying to define um, my substation. Let me try just one more time. Quickly define this. I'm just going to go for a free rectangle this time. And let's add the medium voltage point one more time. All right. We're going to try and define the shape one more time here. Apologies with the troubles. That one is definitely on me. There we are. Place mark. We got our MV point. And now I think we're set. Wonderful. The last thing I'm just going to add is I'm going to add a battery area for us. Since we're talking about BESS today, I have to carve out a little window over here. This might not be completely practical for the purpose of this project, but just for kind of quick and easy use today, I'll just be defining a BESS location wherever I can. And it looks like I'm continuing to change the substation here. Let me just get rid of this one. All right, I'm going to save this as a new site, just to kind of cement things. And I'm just going to reload my page here real quick. since I'm having some issues with that one, I'm just going to go and grab another project that I've created. And this one being similar, just in the fact that I've actually taken this file directly from Prism. You can see a similar instance where I have the available area and restricted area here, as well as a substation and battery. I'm just going to quickly run this design and bring this one up. So same sort of concept. I guess I'll figure out this site a little bit later when my internet starts cooperating with me a bit better. But on this particular location, I'm able to see that I have my panels, substation, and batteries that are automatically filled out just from running the design. At this point, after I've defined the location, I can start to choose kind of my inputs for things like topography, what meteorological data source I want, and then, as I mentioned earlier, getting to things like what equipment I want to select, any layout choices that I need to make, including things like road, structural alignment, your different power station locations, any topography analysis that I need to do. Now, in Prism, we already showed a little bit of that, but we can do a more in-depth analysis here to show the different gradients and then set any kind of limits in earthworks or that cut and fill that we need to do. But focusing here on the best part of things, this is where I can go ahead and define my BESS. So we're working on a much smaller scale for this project, call it 15 megawatts instead of say the 200 that I was going to be working on with that other project. But we still might want a BESS type. You'll see DC BESS here is grayed out. Now this is available, but you will have to be using string inverters for this option. And string inverters, much like DC BESS, being for those, say, much smaller scale PV solar projects. So that'll come into play if you end up using string inverters. But just to focus here on the AC coupled BESS, for wherever our footprint is essentially set down, rated power here is going to actually try and fill out as much of that energy as it can for our AC BESS solution. After choosing our BESS, we're then asked to essentially choose a power conversion system and essentially through there choose our bidirectional inverter. So we have a variety of different inverters here that we can actually pick directly from our library. I'll maybe go ahead and just use the standard one, and then just saying inverters per PCS or power conversion system is going to help us define those actual blocks. And here we can see here, green is going to be our battery PCS and blue will be our battery containers. So for this one, maybe I want my inverter per PCS to only be 2, or 1100 times 2 equals 2200 kVA. And then here, if I want to assume a battery container, we can either, if we're looking at a spec sheet for whatever vendor that you prefer to use for those different battery containers, we can either choose directly here on the energy capacity for the entire container, or if you want to define it in the individual racks, that's just fine. So here, let's say I want my battery container is about 2,000 kilowatts, but actually looking at a spec sheet, it's a little bit different. I might look at the BESS requirements and say, I know that for my project, I want a pretty robust discharge rate or supply cycle duration, which I want to be about 4 hours. You'll see in this case where we don't have those kind of even numbers, but if I were to find a battery container or slash storage inverter combo where the power per PCS and energy capacity per battery container match are direct divisible, then I can have these nice kind of clean numbers. So I can say, okay, I want kind of a really robust battery system to help kind of even out those different points of the day that I either need to absorb or disperse power into the grid. So let's set a 4 hour duration. and then I can further kind of customize here throughout the different PCS dimensions. So in this way, we're able to very quickly find and define a site footprint and then meet whatever kind of design criteria that I need to in terms of a civil sense. So just coming here to apply these settings, I'm going to run the design. And let's just see on my outputs over here on the right, what I'm actually able to come up with. You'll see I've created a few just kind of test runs before, but very quickly the simulation is already done. We're able to see for the solar site how much power we're estimating to get out, energy here on a yearly basis, financial assumptions, and then of course our AC BESS system. So this one is probably quite oversized for our rated power. So 92 megawatts, supply cycle duration of 4 hours, equaling about 370 megawatt hours. This probably being way too much, but not to fear. I can quickly change. Instead of my best requirements set at maximum capacity, just switch it here to specific capacity so I can directly kind of control how large I want it to be just by saying how many PCS. If I wanted to maybe match, and this might be a little bit extreme in this case, but a 1-to-1 for my actual power production to my storage, I could just say, all right, let's put in about 7 PCSs times the 2200 per PCS to get about 15.4 megawatts out. So now just quickly switching that setting, clicking on Run Design, I'm quickly able to realize a much smaller footprint, much less PCSs and battery containers, and getting a more appropriately sized battery. And the neat thing about rated power here is that we can continue to kind of iterate and tweak any of our settings, whether that be the actual site footprint that we were talking about before, the BESS or interconnection facility in the grid point tab here, or any of those basic equipment and layout settings. From here, of course, we're able to kind of click through and compare any of the designs that we'd like. And then just to talk a little bit about the documentation, we are able to see those 400 pages of documents just as soon as that actually finishes generating. Say all of these past 7 ones, these are immediately available for download. So PDF, DocX, we have the CSV and Excel sheets. And then for any of your drawings, that'll include things like PDFs, KMLs, and DXF and DWG, so that they can actually take those CAD files and directly take them to a later stage of engineering design, or pass them on to your team for additional kind of iterations and customizability. So from here, just to quickly show, maybe I just want to look at our BESS system general layout. Really quick and easy for me just to download one of these PDFs. Same here, if I just wanted the actual single line diagram, I can quickly download that. And then let me just open these just to quickly show how fast rated power is able to do that. Here just showing the basic layout for our BESS solution, and then any additional notes here about our actual design choices. And then lastly here, just showing the single line diagram of how everything is going to be connected electrically, all the way down here from the racks to your inverter to your different power stations, including that transformer here. And it looks like there's 3 pages on this side. All right. And that about wraps it up for our rated Prism and rated power portion, showing the actual demonstration. You can see here, just from even changing from these 2 different iterations, uploading the site footprint and making these selections, that just a few button clicks will get you immediately those documents, design choices, and then also any particular results from our platform here. So with that, we'll just proceed right to our Q&A session. I know we only have a few minutes left, but would love to answer some questions from you all. All right, I'm seeing some questions. I'm seeing one from a Cameron, or a couple from Cameron. Can we have a copy of this webinar? Absolutely, you can. That'll be sent out here after this. We'll also have the full kind of recorded webinar up on the site as well. Um, I'm seeing here, would we be able to load our own land layers into Prism? For example, if we have a map of structures, houses in the area of interest, could we import our own setbacks for those? Absolutely. You don't have to use Prism. We give you the option if you use Prism to have those layers automatically created for you. But if you use other programs or you've done your kind of own land surveying, you're absolutely more welcome to upload those directly into RatedPower. Can we design the standalone BESS as well with Prism and RatedPower? Um, Within Prism, you're definitely more than capable of citing for a standalone BESS site. However, in Rated Power at this time, we don't have a standalone BESS solution. Right now, it's either solar or hybrid. I think eventually we will be looking at implementing a standalone BESS solution, but I think that conversation will just be reserved for another time. We definitely hear you. We get that question every once in a while, so we are definitely looking at potentially implementing something like that in the future. Can we build available areas and restricted areas in Prism if we have site coordinates? Absolutely. I imported a file, but if you don't have like a KMZ, KML shape file, CAD drawing to import, you're absolutely more than welcome to go ahead and kind of free draw and create out as you best see fit within our internal site creator. As long as you're actually able to locate down to that site coordinates, you can go directly there. Can you estimate? Let's see. What is this? What about permitting? Is that a separate process or program? Yeah, permitting will be outside of the scope of both Prism and Rated Power. I'll say that for folks that are going ahead and utilizing both the platforms for their solar or other designs, it typically takes place either during kind of Prism, that upfront greenfield site development efforts, or as they start to potentially look to build out that site and come up with a hypothetical design. Folks will go ahead and do kind of permitting after they're able to locate maybe the aspect and buildability of the site. So I kind of seeing permitting as maybe that intermediate phase between the two, or as you start to build things out within Rate of Power. I'm seeing a question here. What countries do they have a database for in Prism? Is it possible to use Prism software in some countries like Africa? Um, at this time, Prism is primarily focused on the US market or North American market, with US having a bunch of the parcel and kind of topographical data. Eventually, I think we might expand out into other markets, but for now, just assume that it's going to be primarily North American and US based. And I think we're at time for the webinar. So thank you very much for joining us for today. I really appreciate it. And any additional questions, please feel free to reach out to myself and the team. Would be wonderful to hear from you. Thank you all for joining.